Are you unsure about setting up the WeldSaver for your application? Hello, Rusty Waters here for Proteus Industries. Today we'll look at how to optimize the WeldSaver for your specific needs. The WeldSaver features an embedded web server that allows you to observe its operation and modify performance parameters on a graphical user interface, accessible from any device with a web browser and Ethernet connection. Here's how the main page looks on a Windows PC using a touchpad or mouse pointing device. You can also use a touchscreen or the Tab key to navigate and the Enter key to select the desired screen element. Simply type the WeldSaver's IP address into your web browser to reach the main page. The standard WeldSaver address is shown here, but you may have specified a different address when you ordered your WeldSaver. But wait, if you're on a PC, there's one more step you'll need to take first: setting your PC's IP address to be on the same subnet as the WeldSaver. Right-click the Windows icon in the toolbar and select Network Connections. Then click Change Adapter Options. Next, double-click the Ethernet settings and click on the Properties button. Now select the checkbox to enable Internet Protocol version 4, then double-click that same line to get the Properties pop-up. Select Use the following IP address and make the first three fields the same as your WeldSaver's IP address, followed by a unique number in the fourth field that isn't the same as the WeldSaver or any other device on your control network. The subnet mask should be set to 255.255.0.0. Click the OK button to save the new IP address. Now you can go back to your web browser and connect to the WeldSaver. Before we dive into changing the WeldSaver setup parameters, I often hear questions about how its advanced cap-off detection works. To understand better, let's look at a graph of the two flow sensors responding to a cap-off event. Notice the return sensor response is often less than the supply sensor because the parallel flow paths on a typical welding gun allow a portion of the flow to continue reaching the return sensor, while the opening to atmosphere results in a big increase in supply flow. This lower response from the return sensor is why relying on a single flow switch on the robot return line to detect cap-off often proves to be a dicey proposition. So, the obvious way to detect a cap-off with two flow sensors is to convert the frequency outputs to flow rates and compare them to each other. The problem with this is time. First, there's the time needed for the difference in the flow rates to get above a defined threshold for cap loss. And then some settling time needs to be added because of measurement uncertainty when the frequencies are changing rapidly, and to avoid false tripping from transients such as water hammering. As you can see, even with a minimal settling time of only a half second, these delays can add up to over a full second. Now, why does that matter? Well, if you're welding once every 2 or 3 seconds, then taking over a second to detect a cap loss is acceptable. But if you want to accelerate your rate to 1 weld per second, you need to reliably detect cap loss in less than a second. Which is why Proteus developed our patented flow accelerometer technology. By comparing the acceleration and deceleration of the supply and return sensor frequencies respectively, we turn the transitions that make flow comparisons slow into an advantage. The result is fast and reliable cap-off detection. But it's difficult to directly quantify the accelerometer thresholds. So to simplify setup, the WeldSaver provides 5 relative levels of detection labeled normal, fast, slow, fastest, and slowest. And as a final note on cap loss detection, the WeldSaver runs both detection methods concurrently, the flow accelerometer as the primary detection, and the flow rate comparison as the secondary or backup detection. The primary detection should always catch cap-offs before the secondary, except when flow to the gun is restarted without a properly installed cap on the gun, in which case there is no opposing acceleration and deceleration for the accelerometer to detect. To adjust the operating parameters related to water flow, click the Setup button on the main screen. The WeldSaver will respond with the Setup screen, where you'll find the Flow tab appears as the default. First, note that you can select between empirical and metric units of measure. Then, to adjust the response of the primary leak detection, select the pull-down menu and choose one of the 5 values ranging from the fastest to the slowest response. If you want to conduct live trials of the primary cap-off response by manually pulling caps, first select the Disable checkbox for the secondary detection, so the flow differential detection doesn't interfere with your flow accelerometer testing. Once you're satisfied with the primary response, you can re-enable the secondary detection by clearing the checkbox and then move to setting up the secondary detection. Select the Secondary Leak Detection text box and enter the desired difference value. Then select the Secondary Leak Delay text box and enter the amount of time in milliseconds for the flow difference to remain stable or settle before triggering a cap-off response. I recommend no less than 2 liters per minute and 500 milliseconds. Lower settings will give you faster secondary detection, but at the risk of triggering false cap-offs. To conduct live trials of the secondary cap-off response, select the Disable checkbox for the primary cap-off detection. Once you're satisfied with the performance of the secondary detection, you can re-enable the primary detection by clearing the checkbox. Not to be confused with the delay value for the secondary detection, the stabilization delay input box specifies the amount of time the WeldSaver will allow for the sensor flow rates to stabilize immediately after the shutoff valve is turned on. This allows for any air trapped in the robot hoses during a cap change to be purged before flow measurements begin. Set it to as low a value as possible without triggering a false cap-off when the shutoff valve is reopened. If you're using the EVAC, an unavoidable consequence of achieving dry cap changes is that more air will be trapped, so longer stabilization delay times are necessary. You can save the cap-off settings at any time by clicking the Submit button, which will return you to the main page. But let's continue on with the other flow settings. The WeldSaver can provide a warning if the flow rate falls dangerously low. Select the Flow Warning input box and enter the flow value where you want to receive this warning. When the flow rate falls below this warning level, the flow status indicator on the main page will change to yellow. At the same time, the adequate flow bit on the control interface will change from 1 to 0 to alert the robot controller. The WeldSaver similarly provides a fault indication if the flow rate is inadequate to safely continue welding. Select the Flow Fault input box and enter the flow value where you want this fault to occur. When the flow rate falls below this fault level, the flow status indicator on the main page will change to red. At the same time, the minimal flow bit on the control interface will change from 1 to 0 to alert the robot controller. And here's a little trick to optimize your robot controller efficiency. The minimal flow bit also drops to 0 when a cap-off is detected. You'll want to immediately halt welding in either case, so the robot controller can treat the minimal flow bit as an OK to weld status bit. Now let's save all of the flow setup selections by clicking the Submit button, and the WeldSaver returns to the main page. To adjust the temperature operating parameters, click the Setup button on the main screen, and again, you'll find the Setup screen with the Flow tab appearing as the default. This time, click on the Temperature tab where you can select between empirical and metric units for temperature measurement. To receive a warning if the water temperature approaches dangerously high levels, select the Outlet Temperature Warning input box and enter the temperature value where you want to receive this warning. When the water temperature rises above this warning level, the temperature status indicator on the main page will change to yellow. At the same time, the outlet temperature warning bit on the control interface will change from 0 to 1 to alert the robot controller. The WeldSaver further provides a fault indication if the temperature is too high to safely continue welding. Select the Outlet Temperature Fault input box and enter the value where you want this fault to occur. When the water temperature rises above this fault level, the flow status indicator on the main page will change to red. At the same time, the Outlet Temperature Fault bit on the control interface will change from 0 to 1 to alert the robot controller to cease welding immediately. And as with the flow setup, click on the Submit button to save the temperature settings and return to the main page. If your WeldSaver is equipped with the EVAC coolant delivery and extraction valve, there are a few more settings to consider. Click on the Setup button again, and this time click the EVAC tab. The Change Verification Delay input box is the most important here. It establishes how long the WeldSaver waits after the valve is shut off to signal sufficient vacuum has been reached to proceed with a cap change. You can experimentally set this to the shortest time that the EVAC takes to generate a vacuum in your application. At the end of the change verification delay, the WeldSaver will set the Change OK bit on the control interface, signaling the robot to begin an automatic cap change sequence. If you select Change OK Detection by Coolant Flow, the WeldSaver will also use the return flow sensor measurement to determine when to signal it is okay to change the cap. The Valve Fault Delay input box sets the amount of time that the WeldSaver will wait for flow to the gun to stop after shutting off the valve. If water is still flowing after this time, the WeldSaver sets the Valve Fault bit on the control interface, indicating a problem such as a disconnected valve cable. Setting this to 1 second is adequate for the EVAC. And finally, if you're using the EVAC with a tool changer, you may want to stop the EVAC suction while the gun is parked. You can do this with the electric version of the EVAC by simply setting the Tool Change Output bit from the robot controller, and the WeldSaver responds with the Change OK bit. But for the pneumatic EVAC, you must also open the shutoff valve and depend on the tool changer to stop the flow when the gun is removed from the robot. Set the tool change delay to the number of seconds you want to allow before the WeldSaver starts checking to confirm that the tool changer valve is closed. If water is flowing after the tool change delay, the WeldSaver will shut off the flow, which on the pneumatic EVAC restarts suction and sets the change fault bit on the control interface to notify the robot controller that the tool changer valve didn't stop the flow. That covers the WeldSaver setup. If you have questions, contact Proteus Technical Support for help. With the WeldSaver, you have not only the world's most advanced coolant management for robotic welding, but also access to Proteus's vast experience in liquid cooling measurement and control. We'll always go the last mile to make sure the WeldSaver gives you the best possible performance. Thanks for watching.